All right, hey guys. I want to go through just a quick setup of how you might set up the probabilities for this radioactive decay MATLAB problem. Um, Kind of walk you through my setup for it, and hopefully just set you off on a good start for finishing up this problem this week. Um, if you have questions with it, feel free to shoot me an email. Obviously, like I'm super flexible on deadlines, right? So if you don't get it done by today, no big deal. But let's try to get it done by early next week. If we don't, so by shoot me an email, include your file so I can take a look at it to try to give you some guidance in terms of um, how we can improve upon it or what mistakes we might be making. So um, let's just walk through this. So basically, this is set up very similar to what the template was for you guys. Um, and now what I'm going to do, so I'm kind of looking here now, right? So, but now what I'm going to be looking at is if we look at the assignment itself, so after 10 years, what's the probability of one particle remaining? What's the probability of 5, 10? And then after 10 years, what's the expected number of particles to remain? So how can I have that set up here and what's that going to look like? So I'm just going to go through for what's the probability for one particle to remain. Um, and then obviously you can just kind of model the after 5 particles or 10 particles. And then I want you guys to try to just come up with your own method of figuring out what's the expected number of particles to remain after the 10 years. So here's what I have. So I set up a new variable, results 1, and I name it results 1 because it's the results that I'm looking for after for just one particle, right? So what I'm going to do is I'm going to do a loop, and I'm going to do a loop where I is equal to 1 through trials, and again at the very top, I've set my trials to 10. Okay, and so what I want is I want 10 trials, and the final point that I have is radioactive. So let me see if I can pull this up. So radioactive is my variable that's going to show me how many atoms are still radioactive after each trial. And so what I'm going to do is I'm going to see if radioactive index value 1, right, because that's my first loop, if 1 is greater than 1. If it is, then, or if it's greater than or equal to 1, excuse me. If it is, that means that there's at least one atom still remaining. So what we're going to do then is we're going to take results 1, which was set at 0, and we're going to increase it by 1, and then we're going to calculate the probability. So a new variable here, probability 1, is going to be my results 1 divided by my number of trials times 100. And I'm going to end that and that. And basically I'm going to do that 10 times. I'm going to run this loop 10 times. If my radioactive number 2, because it's going to go from 1 to 2, is greater than 1, I'm going to add results, and you'll kind of see. So let's run this. Sorry. So let's run this to give you guys an idea of what this looks like and how this is calculating a probability for me, right? Okay, so here's my output, and I specifically didn't put a semicolon here just so we can understand why this makes sense. Okay, so if we look at my 10 trials, trial 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what I see here is these are basically every trial has one atom, right? So my probability that one atom should remain after the 10 trials should be 100%. Okay, so what we're going to see it doing is after 1, it was 10% because what it did was it found that the first trial had 4, so that's greater than or equal to 1. So it moved results from 0 to 1. It then took that 1 divided by the number of trials, which was 10, and multiplied by 100. Right? So 1 over 10 times 100 is 10. So 10% probability. Each time it's going to increase my results 1 value by 1. So I see 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. And my output here basically the probability of radioactive atoms remaining after 10 years. I did a number of different printfs. I'm just showing you one here. For one atom to remain is 100%. Now let's actually change this. I'm going to change that to 0. But just want to point out here, this double parentheses sign, it's kind of funky. If you just click one parentheses sign, it actually doesn't like that. It shows up an error there because remember the parentheses sign is trying to find some variable. So I'm not sure exactly the intricacies as to why it's not liking that, but it says obviously line 55, it doesn't like that. So if you're trying to put that parentheses sign as like, hey, I want you to write that in the script, go ahead and include that double parentheses sign, and that should take away that issue for you. So we'll let this run again. 100% again, great. And then again, it's calling on this 0 decimal places, right? So that's why I changed that to 0. So we see this is now just 100 instead of 100.00. That double decimal point, or the what's that? 1/100th of a percentage isn't really necessary in this case. But this parentheses here is calling upon this variable here, probability 1. So we're recalculating that each time we're doing that loop, okay? I then had another print where after 10 years, the expected number of atoms, in this case is 4.1 atoms. These are the results that I got from that, so I'm gonna give you guys an opportunity just to try to figure that out. It's not a hard mathematical process, but kind of give you guys the opportunity to look through that. So again, all you gotta do to add on to this, we want to see what's the probability of 5 atoms remaining. Now what we see here is it should be less than 100% because we should see here we have 1, 2, 3. In this case, we only have a 30% chance, but we want our program to calculate that for us. What's the probability of 10? In this case, it should be 0 because none of them have 10. So that's the process. Again, let me know if you have questions, and hopefully this will be kind of an easy way to end the week. Right? Oh, over here.